Good morning, everyone. Vince, I see you've joined us. So I think that is everyone today. We're going to go ahead and get started with our last Water Quality Wednesday of 2025. This was the one that was scheduled for January. We did have to reschedule it to today. So I thank you for joining us. Just some other housekeeping items or events you might want to mark your calendars for. Our next Certified Livestock Manager webinar will be on June 2nd. This is from 10 a.m. to 11:30. Topic is still to be determined, so you can register for that at go.osu.edu/CLM. This does wrap up our Water Quality Wednesday for this year. So in 2026, we will be rolling out this series again. So stay tuned for those dates. We'll release them at the end of the year, so you can put those on your calendar as well. Some other upcoming extension events. We have the North American Manure Expo, July 30th through July 31st. This will be at the Fulton County Fairgrounds in Wauseon, Ohio. For more information on that, you can go to manureexpo.com, and there's a whole list of events and sponsors and all of the good things on there for that event as well. On August 28th of this year, there is a Drainage Water Management Field Day in Lima, Ohio. We don't have any information yet for that out, but there will be some shortly, so stay tuned for that. And just in case this is your first time watching us, meeting us, or you need a refresher, today's webinar is brought to you by the OSU Extension Water Quality Team, and our team consists of various different team members. We will start here at the top in Williams, Fulton, and Lucas counties. We have Heather Torlina. She's joining us today online as well. Paulding, Defiance, and Van Wert counties, we have Rachel Cochran. Allglaze, Mercer, and Allen counties, you have myself, Jocelyn Rubel. Putnam, Hancock, and Hardin counties, we have Paige Garibrandt. We do still have a vacant position in Crawford, Wyandotte, Seneca, Sandusky, and Erie counties. And we also have Amber Emmons covering Henry Wood and Ottawa counties, and she will be one of our speakers today. For more information on us or to find out what we're doing, if we're doing anything in your specific county, please feel free to go to our website. It's waterqualityextension.osu.edu. So today's webinar, we are going to be focusing on some of our team's research. We do have 3 speakers today. We have Vince Kelly with Green Eyes, Heather Raymond from The Ohio State University, and Amber Emmons from The Ohio State University as well. So with that, Vince, you are up. I'm going to stop my sharing. And you should be able to share.
Okay. Well, thanks very much for the introduction. And a big thanks go to Heather and Amber. And Amber's been working tirelessly in the field to support these instruments and these high-frequency nutrient measurements for some years now. And we're really grateful for the efforts of customers like Amber, because Green Eyes is on a mission to provide accurate high-frequency nutrient measurements, which is something that traditionally has been very difficult to achieve. So historically, to measure nutrients in field sites, we would go out, collect a grab sample or hand sample, take it back to the lab. It would probably sit in a freezer or a refrigerator for some months. And then eventually we'd get a result, and it's fairly laborious and fairly expensive to process all these samples. But perhaps the biggest weakness in our old traditional method was the time scales that we could hand sample or grab sample on just do not resolve the dynamics that are driven by, let's say in Ohio, principally rain events. All right. Coastal areas, it could be tides and lots of other things, or algal blooms have have a big effect. Um, but and I'll provide some data from the OSU site, and you'll get a sense for these concentrations often change very quickly, surprisingly quickly. And so there's been a need for instruments like Green Eye's New Lab, which is doing the same wet chemical analysis um, in the field that most laboratories would use to make the same measurement. So
Yeah.
usually the
Do you
results
have
are,
slides that you're supposed to be sharing?
I do have slides that I'm going to share. I just
Okay,
wanted to
just wanted
give
to
a,
check.
yeah, thank you, thank you. And when I forget to share my screen, please remind me because that seems to be a hiccup that I have often. So traditionally, our sampling just didn't resolve the sort of dynamics. And if you were trying to calculate loading or loading estimates, it was very hazardous to do that with low frequency data. So about 20 years ago, I started working uh, in the lab with these high frequency types of instruments. I later formed Green Eyes and we took over manufacturing of new labs, and it's been a journey. So these are not like traditional water quality sensors, which would be optical or electrode based, which are easier to deploy for sure. The new labs use bags, IV bags of chemicals. So the um, traditional water quality sensors for oxygen, temperature, conductivity, and pH and chlorophyll are a little easier to deploy. They have their own set of challenges, actually, that the new lab has some ways of working around. Um, but it's been a journey to get these instruments to work well, improve reliability, and maintain accuracy. And that has been a fundamental tenet for Green Eyes that uh, we we have to produce accurate data, and I'll explain a little more about that. But I guess the sort of point of my ramble here, or pre-ramble, is that Green Eyes relies on the attention to detail and dedication of our customers while we're on this mission, and we just simply we can't do it. We have some customers that um, aren't always so careful and dedicated, and those results aren't as good. And so we're really grateful to Amber and the folks at OSU who have stuck with us and done a great job. Okay, let's see. I'm on a completely new computer system, so hopefully, um, okay. And actually, I need to go back and select share. Yep. Um, my screen now, yes?
Yeah, we can see it as if you're going to edit the PowerPoint.
Okay, right. So we'll get slideshow. Great. Thank you for confirming. Uh,
That looks great.
okay. All right. Good to know. Yeah, so we've been working with the extension service from the Ohio State University. I don't know, it's got to be at least 4 years, some 3 or 4 years. And I'll tell you, we're grateful because we've really learned a lot in that time. So this is a picture of a new lab instrument that just out in a typical setting, right? Edge of a farm field, receiving waters. Um, and I'll advance to the next slide. And here you can see a unit set up to measure soluble reactive phosphorus. This would be like dissolved phosphorus. And the way the new lab works is it sort of replicates what we would do in a lab. It has a syringe instead of a test tube. It has this very compact valve where we can, excuse me, I'm on auto feed, that may happen. We have a compact valve where we can add sample water to the syringe. We can add color forming reagents, and then we can move over to this gray box up top is an optical detector where we're going to shine light at a fixed wavelength through this colored solution to do colorimetric chemistry. So the new lab is doing the same type of analysis that you might do with a swimming pool test kit to measure chlorine, where you're going to dip a cuvette in the water, add some color forming reagents, and then let the color develop. And, on your swimming pool, you might hold that color up to a slide that say, oh, it's about this darkness of yellow, which equates to about 0.1 milligram per liter of chlorine or something like that. So the method is the same for the new lab. We're just doing it with a little more precision. So when we mix these reagents, and there are specific reagents for each nutrient, nitrate, phosphate, we do ammonium, we can do total nitrogen, total phosphorus, that we're going to actually form that colored solution inside the detector and shine a wavelength through it to calculate an absorbance, which we can relate to concentration. One of the interesting features about the new lab, and this is where I said accuracy is so important, is it'll run an internal standard in front of every analysis. So one of the bags hanging on the instrument is a 0.2 milligram per liter phosphorus standard. And I think actually for the OSU folks, the concentrations are a bit higher, so we may have a higher standard than that. No, I think that's right, actually. So we'll run that standard through the same analysis that we're going to run the subsequent sample on. And we'll use the results of that standard to calibrate the concentration of that sample. So that if things like temperature or different reaction conditions, principally temperature, but also perhaps some of the reagent performances could change slightly, or just general performance of the instrument. There's like subtle things here that can change. Principally, we are talking about the influence of temperature on the signal. So we really want to calibrate in front of every sample to maintain accuracy. The other thing that does for us is it tells us instrument performance. We have a good record of how the instrument is performing. And when I said that the traditional water quality sensors are a bit easier to deploy than the new labs, which is true. However, they don't have these types of internal standards where we can track performance as well as the new labs. So, this is it's quite a different beast. It's a little more work, but we get a lot of information. So that's the general way the instrument works. To the left of the new lab is our controller, which sends sampling commands and collects data and sends that data out to the internet in real time. We'll see if we can actually pull up some real-time data. These are just a couple of other locations that Green Eyes has instruments. This is Moses Lake, Washington, where we don't have a sampling shed or building like OSU has. Green Eyes will put the instruments inside a waterproof enclosure, run everything off of a solar panel. This is another site in Virginia. There's 3 different instruments inside the enclosure, solar panel, batteries, cell modem to get the data out. Another site in San Francisco Bay. This is phosphate and ammonium with some accessories to run pumps and maintain cleanliness of the instrument. These are calibration curves that we generate in our laboratory from the new labs, and they just show that the instrument's response is very linear with concentration. And this is a typical thing that any nutrient lab would do where they want to verify precision and performance of the instrument. And these graphs show that the new labs are comparable to, in terms of precision and accuracy, to traditional instruments that you might find in an analytical services laboratory. And here we actually have some OSU data from May of last year. And what sort of jumps out at you is there are some really dynamic changes going on, and where if we were collecting samples with grabs, it would be very difficult to resolve these large changes. I mean, it's in this month of May, it was probably a pretty wet month, and it was just the nitrate signal was moving all over the place. And you know, we had a big rain event. It drives the concentration to 10 milligrams per liter, which is quite high, not shockingly high for a strongly agriculturally influenced site. And then we have a dry period. You can see the nitrate concentration just gradually coming down, and then boom, another big rain event. And this is what I said, that it can be shocking how quickly concentrations can change with events. And so really these data points are 2 hours apart. And so in certainly less than a day, the concentration goes from 4 to 12 and a half, right? So more than threefold in certainly under 24 hours. And then it comes back down immediately, right? And so these are the types of dynamics that the new lab gets us to observe that, oh, many years ago, when we first started deploying these instruments, we were sort of overwhelmed. We saw these in coastal areas where nutrient concentrations change with tide and other drivers at scales we hadn't seen. We have some other sites where the streams are really flashy. So at this site, there's a large drainage pond that's going to sort of actually mute some of these signals. So if we were sampling perhaps at a stream feeding this pond, the signal changes over time might be even faster. So the point is that the new lab allows us to resolve these high frequency changes that we wouldn't otherwise see, to calculate loading estimates that we wouldn't with much greater accuracy and confidence. And ultimately, what's exciting now is many of our customers are implementing nutrient management programs with, it could either be wetland restoration, it could be treatments to remove phosphorus from the water column. And we're getting to use the new labs to evaluate the effectiveness of nutrient management programs. And this is something that's really exciting. So for the first couple of decades I've been doing this, it was mostly just measuring nutrient enrichment. But I think we're turning the tide on that. And we've gotten, and as a nation and perhaps globally, people are getting creative and about trying to reduce nutrient enrichment. So we're really excited to be part of that. On the lower panel is soluble reactive phosphorus. I think these data points were from a period where we had perhaps an inlet problem. So these data points are not accurate, and we'll filter them out in the final data. But the same story for phosphorus. You know, we see some daily wiggles, but it can change quite dramatically, and it has a different behavior than nitrate actually, because it has different reactivity in the soil, different biological reactivity in certain circumstances. So they often have similar patterns, nitrate, phosphate, even ammonia, but they're certainly not the same. One often lags the other. Green Eyes has plenty of other sites, and here, this is something I talked about, the signal from the onboard standard. And we like to see that the onboard standard is relatively stable over long periods, and it's a little bit influenced by temperature. And so these wiggles during the day are really just temperature signals. And of course, we're going to calibrate under that temperature regime, so it doesn't affect accuracy. And one of the ways we know that is those little wiggle pattern in the standard aren't reflected in the sample concentration, right? So this is a different site, sort of same story, rapid dynamics. And here we have another site with soluble reactive phosphorus, and another parameter that we have added is total phosphorus. And this allows us to measure all forms, organic, particulate, dissolved phosphorus as well. which is something that we developed after we got started with Heather and Amber, but something I might be pitching to them in the short term. And we also do total nitrogen as well. And so up here we have a nice flat standard curve, standard line, little influence of temperature, and then we have some dissolved nitrate, and we have some big signals from total nitrogen. And the total stuff is really quite new. We've had a lot of our customers have been really kind and patient with us and working with us, and have given us some really nice testimonials that I won't bore you with too much. I don't think that was the purpose of today's talk. But I would say that, Green Eyes, along with our customers, are really jointly on this mission and have advanced this effort significantly. We have some other anti-fouling products that I won't bore you with. But I think that essentially that sort of concludes my talk. Yeah, I think it does, and I better leave some time for any questions that anyone has, or if anyone wants to add anything.
All right, perfect. Well, if you guys think of anything, feel free to drop them in the chat in the Q&A box, and I'll kind of monitor them. And if we don't get to them today, Vince, can we email you with those?
Please do.
Perfect.
I'd love, questions, feedback, welcome it all.
Perfect. And with that, Heather Raymond, you are good to present up next.
Okay, great. Vince, I'm going to have to share, since you aren't able to stay long, I'll have to share this presentation with you later. Make sure you see the webinar, because there's some really cool stuff we've done with comparison of our data and some grab data and kind of some things we're learning about the nitrogen that we would have never found out if we didn't have the new lab data. So I'll have to provide you a good testimonial. Okay, now, can you see my slide and not my presenter view?
Correct. That looks good, Heather.
Okay, wonderful. Okay, so good morning, everyone, and thank you for joining us. Today, I'm going to discuss some projects we're working on to help reduce nutrient losses in the Little Auglaize River upstream of the drinking water intake for the city of Delphos. This work was completed by a large team of OSU Extension staff, faculty, and students over multiple years. Vince was correct. I think it's been about 4 years that we've been going on this. And I'm just going to provide some highlights and then discuss our plans moving forward. And I have to make sure I can move where I'm seeing people so I can change my slides. Okay. So why Delphos and why this particular watershed? Well, you may not be aware that the drinking water source for the city of Delphos is impacted by elevated nitrates as defined by concentrations above the drinking water maximum contaminant level of 10 milligrams per liter. And Delphos is able to continue to provide safe drinking water to its customers, thankfully, but it's only by the use of avoidance strategies. What they do is they turn off their intake to the reservoir during these times when the river water quality is bad. But the problem is this avoidance strategies are really their only option because nitrates cannot be removed by conventional water treatment. And the overall problem with avoidance strategies is the city is finding it increasingly difficult to find times when the water levels are high enough to turn on their pumps, but nitrates are low enough to be safe. And even when nitrates are less than 10, lower levels of nitrate, along with the phosphorus loading this watershed, can help fuel toxic, harmful algal blooms on their reservoir. The city has dealt with several severe HABs and has had difficulty removing the toxins they have produced. And it's also extremely expensive for the advanced treatment needed to remove HAB toxins. So it's both an economic burden and a human health risk to the residents. So these drinking water impacts have resulted in Ohio EPA listing this watershed as impaired for nutrients and triggered development of a nitrate TMDL due to these local impairments. And this will be the first nitrate TMDL for an inland watershed in Ohio. So this is a very high priority for the state. Also, subwatersheds upstream of the intake have been identified as having a high potential for nitrate and phosphorus losses, which also contribute to the nutrient impairments to Lake Erie. So a couple of reasons why this is a priority here. Here are some pictures of the drinking water intake taken at different times of the year to give you a sense for what the water system has to deal with. In the upper left, you see the drinking water intake during the summer, and you see all this algae. So the nutrients are fueling a huge biological response within the stream, and the flows are often too low for the water system to pool water into the plant, into their reservoir. In the upper right, you see kind of ideal conditions. This is when, river flows are kind of moderate. This is more in the early summer. And I'm sure the water system is probably actively pulling in water to fuel their reservoir at this point. In the lower left, it's a winter rain event, and you kind of see that chocolate milk, that looking water that we see, phosphorus and total phosphorus and nitrate was pretty high during this event. And then the photo next to it is kind of a spring rain event. Again, you also see all this debris right at the intake, sometimes clogs the intake, poses a lot of maintenance problems for the water supply. And then the last picture in the right is actually a planktothrix rubescens bloom on the city of Lima's reservoir. I couldn't find the bloom on the city of Delphos reservoir, but these are really funky. They are winter blooms that occur in November, December, January. When water temperatures are really cold, they're very difficult to control because algicides don't work in the winter. And a lot of times we're seeing kind of these winter nutrient loads. And that's when the water system's trying to feed their reservoir because the water levels are high enough. It's not summer, but then they're pulling those nitrogen and phosphorus levels that are helping to contribute to these blooms. So lots of problems the poor water system has to deal with. Next, I'm going to talk a little bit about models, and this is the entire Maumee watershed in the tri-state region. And when I'm talking about models, I like to start by paraphrasing a quote that all models are wrong, but some can be useful. So to that end, there were multiple soil and water assessment tools, or SWAT models, developed for the Maumee watershed by universities, including OSU and the federal government. But since everyone was kind of arguing over which model was right, researchers decided to work together to compare model results and help determine if these different models, that using somewhat different assumptions, perhaps based on the researchers' experience and background, but seeing if they consistently predicted areas with high potential for both phosphorus and nitrogen loss, and if there were some areas that contribute to higher nutrient losses than others across the watershed. And these are just a couple of figures I pulled from this report. With modeling results to show that the southern portion of the Maumee Basin was having a higher potential for nitrogen and phosphorus losses. And the models typically agreed with this. And this kind of makes sense. The soils are a little different in this area. And you also have a little bit higher topography, which is relative in Northwest Ohio, but that can help contribute to increased potential for loss. And the Delphos watersheds are within the red circle area on those figures, showing that higher potential for nutrient loss. So to help address both the local drinking water impacts at Delphos and the regional nutrient impacts to Lake Erie, OSU Extension and faculty established a partnership with the City of Delphos, Ohio EPA, NRCS, and Cargill. We brought in Green Eyes to help us with the modeling and the real-time sampling. And we are monitoring water quality to determine nutrient loss timing, inform those agricultural best management practices, both placement and selection, measure those water quality changes, and very importantly, assist the drinking water plant in determining the times when it's safe to fill the reservoir. And I'll go over some examples there. We're also updating and refining the SWAT model to assist with development of Ohio's first nitrate TMDL and to help evaluate the impacts of those management practices. We developed non-point source implementation plans with our partners for the upstream watersheds of the city of Delphos. And Amber will be talking next about some of the field trials that we're doing in the watershed and how we're promoting BMP adoption and ongoing implementation within the watershed. For those unfamiliar with this area, the land use in the watershed is dominated by row crops, seen in the upper right, and there's only one small municipal wastewater outfall in the watershed, and that's in Ohio City, kind of where that 7.7 on the nitrate graph to the left is. We have sampling locations located throughout the watershed and the sub-watersheds and have collected over 2,000 water samples at these locations, kind of in addition to the high temporal frequency data of the new lab, we wanted to see what the spatial variation was. And this map at the left shows a snapshot of sample results collected in January 2021 when nitrates were elevated, but we've actually seen higher nitrate results than this in the watershed. This is just one example. So in addition to the weekly, bi-weekly sampling at our upstream stations, we have the new lab at the Delphos intakes and intake. We collected data is reported in real time, and the system is checked at least every 2 weeks. I won't go more into that since Vince did a good job. But this is an example of what the online dashboard looks like with all of the data. And this is what Delphos uses to help determine if it's safe to turn on their intake. And in this case, even though there was a precipitation event, you kind of see in the right-hand, lower right-hand panel, and the flows increased, the nitrates remained stable. And it's at 6 in the water system knew that even though they had that rain event, nitrates were low enough that they could continue to pump into their reservoir. So that's very important for that real-time decision-making. And this is a 1-year time series from the new lab compiled by Shannon Pace, who's a grad student under Professor Steve Lyons. And you can see how in some cases the nitrogen and phosphorus increases following rain events. And this is especially true in the spring and winter, but the response is slightly different in summer. And there's some differences between how phosphorus and nitrate responds. And I'll go into that and why that's important to understand in the next couple of slides. But first, in addition to concentrations, you need stream flows to develop the nutrient loading to streams. So Shannon went out and measured stream flows at a variety of water levels in both the Auglaize and some of these, that's the picture in the right, and some of the smaller tributaries that feed into that. And then you can establish something called a rating curve. And then if you know the water level, you can determine what the flow in the river or stream is at that time, and then you can figure out what the loading is. So this was incredibly important for us. And this graph is showing, and this is what I thought you'd be interested in, Vince, the potential impact of sampling frequency and timing on these phosphorus load estimates. So what we consider the quote unquote real data is the 2-hour time series data from the new lab. That's kind of this middle gray line. And what was interesting is what Shannon did was she said, okay, looking at all the new lab data, if I took the weekly minimum concentration from the new lab and plotted out those loads, load would be, less than 1,000 here or less than 2,000. Whereas if I looked at that new lab data and looked at the weekly maximum and went out and sampled on that event, then load would be, to over 10,000. So what this shows is that, especially when you have rain events, having that data is going to be incredibly important. Otherwise, you could potentially very greatly overestimate what the load is or underestimate the load is. If you're a sampler who doesn't like to get wet and only wants to go out and sample on a sunny day, then you might be in this kind of lower estimate. If you're someone who's like, I really want to catch all those high flows and is always doing the highs, then you might not be getting the averages and the lower concentrations, and you're going to overestimate your load. So we found this incredibly useful. The other thing we found useful was that in the summer period, at least in this water year, we didn't see much impact of precipitation on loads. And of course, this is because the crops are utilizing those nutrients. You're getting less runoff because you have less bare ground. So it showed that the importance of those higher frequency sampling is perhaps greater in the spring and late fall, early winter than during the summer. So if you have to decrease sampling to only weekly or bi-weekly, doing so in the summer might be more appropriate, but having that higher frequency sampling in the other seasons, at least in Ohio at this site, is important. We saw the same thing was true for nitrate loads. And again, in summer, at least in this water year, we didn't see as much of an impact. So moving on from that, we wanted to know how well the existing SWAT model, going back to those models again for the Maumee, which was calibrated based on data from the Maumee River near its outfall to Lake Erie, was it predicting the nitrate values for the little algae? This is important for developing the GMDL, seeing which practices are going to work, understanding relationships in the watershed. So those models, and I'm sorry, this is quite a busy graph, but those models results are in red. So the actual data, sampling data, and this was at a USGS gauge station at the algae, because when we did this first model, we didn't have enough new lab data to do this sort of calibration, but we're going to do that next now that we have about 4 years of data. But at that lower monitoring station, that existing model predicted we're getting up to 60 milligrams per liter contribution from the little algae. And this is what's they're estimating loads for the Lake Erie TMDL. So in these upper watersheds, this doesn't actually work very well. And so we the correlation was poor, and the existing model predicted extremely high values in response to those rain events. So to help better understand nitrate loading in the little algae, we recalibrated that existing model based on data from the little algae, and those results are in blue. So, we improved this. So this was work by Margaret Calzett and Asmita Murmakar, and we're continuing to refine this. But the problem is here. So even though we recalibrated it and it looked a lot better, it's still not great. R squares of 0.18 aren't good. So a lot of this is that nitrogen is behaving differently from phosphorus in this watershed. And instead of seeing these really nice predictable rain event responses, which a lot of the models are assuming and calibrating to, we're not quite seeing that with nitrogen. And here's an example. So in this example, and this is Ohio, new lab data again, phosphorus concentrations rise, that's the green dots, following a rain event, and the rain event is shown in this blue in the upper right-hand panel. And we saw the increases in stream discharge, but nitrate concentrations at that same time decreased. Now, this response was not always seen. In many cases, nitrate did increase following a rain event and even persisted for longer in the stream before declining compared to phosphorus, which tended to have much flashier, quicker up and down responses. Now, there are multiple factors to consider for why these responses differ, including in stream nutrient uptake, if you have a lot of that algae in the stream utilizing that, and mobilization of nitrogen in or nitrate in soil as the water table rises and falls, and changes in response when flows are dominated by tile drainage versus when we might have a deeper groundwater discharge impact index. And I think that's what we're seeing here is we had that rain event, and most of that nitrate was maybe coming from groundwater. The rain event diluted the groundwater, and we saw that suppression. So trying to understand these systems is critically important. Because understanding when those losses occur is key to understanding how to minimize those losses, and then estimating which BMPs might be most effective at mitigating those problems. Okay. So I started explaining all this and some of these problems to a friend of mine at USDA ARS in Beltsville, Maryland, a really great chemist. And he said, well, maybe we can use MESA as a nitrate tracer. So MESA is a metabolite of metallochlor, which is obviously for farmers in the area. It's a herbicide that is widely distributed alongside fertilizer in agricultural systems. And MESA forms in soils and leaches very similarly to nitrate. So what you can do is looking at these different stereoisomers, this is where the chemistry gets a little crazy. You can use those to date, track, and age the nutrients in the system. So you can determine kind of which percentage of your nitrate is coming from groundwater versus surface water using this potentially. And there are additional tools like nitrogen isotope tracing that we're considering, but MESA is really valuable in understanding this kind of nitrogen movement. So again, this gets into the weeds and the details. These are some slides my ARS partner gave me, but there's 4 different isomers of MESA. And what's interesting is one form occurred prior to 2000, but after around 2000, the dominant product formulation made by the metallochlor manufacturers was changed. And so we know that if you have old water, groundwater prior to 2000, then you're going to have a different characteristic when you measure this MESA than if you have younger groundwater. So this can help you determine flow paths and older. Bye, Vince. Thank you. I'll send you the slide. So this can help you date the nitrate and see if you're getting kind of older nitrogen response from groundwater versus newer. So and do tracing. So we found in prior, or my colleague has found in prior studies in other watersheds that MESA and nitrate correlated closely in these ag influent systems, and the flow rate of water influenced those relationships due to the addition or removal of groundwater intrusion into that surface water, and relationships strongly correlated. So we thought, can we do this in Ohio? This was done in the Chesapeake Bay. It's done in other areas. Could we do that to kind of understand what's happening in the Little Oglays? So very, very preliminary data. Nothing's been published, but he collected some samples just one day in the Cuyahoga, the Sandusky, Maumee, and then they used some of our Little Oglays data just to kind of see. And I guess first off is you can see that MESA concentrations are lower in the Cuyahoga, slightly higher in the Sandusky, slightly higher in the Little Oglays, and higher in the Maumee. And that makes sense because there's less agricultural production in the Cuyahoga watershed. It was kind of served as a control compared to the Maumee. And so that part was good, but we weren't really getting those strong R squares. And in part just because we didn't have a very robust data set. So one of the things we're doing is we're going to send, or actually they're coming down next week. We're giving them all 2,000 of our archive samples, and they're going to analyze them all for MESA and also sucralose. So sucralose is an indicator of human wastewater. So in addition to doing the nitrate source tracking, kind of determining if there's any wastewater component to this or a stronger wastewater component. So we've got a couple additional questions. It's all very preliminary, but I wanted to kind of show that, we're trying to figure this out. Okay, moving on from all the chemistry, we also, this was the Water Quality Extension Association staff developed agricultural conservation planning framework for the watersheds upstream, assessments upstream of the city of Delphos intake. And these were included in the non-point source 9-element plans, implementation strategies that they assisted with developing. And this is a GIS-based tool that NRCS first established that identifies suitable areas for structural BMPs based on the local soils, hydrology, and kind of topography. So OSU completed these assessments for all the watersheds located upstream of the city of Delphos, and then developed an online mapping application to view the results. So if you are located within this watershed, and we have some other areas of the state that we've also done this for, and would like access to this tool, please contact us. We think it's really helpful. We're working with DNR, providing that to them, because of course this panel on the bottom right talks about areas on site that might be suitable for nutrient removal wetlands based on kind of the local site characteristics. So this can be used as a planning tool, and if especially if there's areas of a field that are prone to flooding, and it looks like it's a good catchment area for this might be a good H2 Ohio project to implement, for example. So hopeful that this can be more broadly used. I also wanted to note that there's still funding available under the Tri-State Maumee Watershed Regional Conservation Partnership Program from NRCS, and these are the focus areas, the Little Oglays and other watersheds in Northwest Ohio are included, also some in Lower Michigan and Northeast Indiana. And if you're located in one of these watersheds and you're interested in this funding opportunity, please see me. And you'll notice that these priority areas were selected based on those SWOT modeling results, showing, hey, this kind of these upper reaches of the watershed are where we're seeing higher potential for those nutrient losses. So that's where they're focusing some of the additional funding. So to end, some next steps, we're going to continue our water quality monitoring. We're going to analyze the historic samples from MESA and sucralose with our partners at USDA ARS to help understand that nitrate source tracking question. We're going to evaluate nitrate transport data and the water quality trends and continue to do so, and use that data to help refine the Little Oglays SWOT model, evaluate impact of BMP implementation, and test new BMP scenarios. So seeing what tweaks can we make that are going to have the biggest impact on local water quality and biggest water quality improvements, and how can we help promote adoption of those. We're going to determine if SWOT model calculations can be updated based on the MESA results that we're currently going to be analyzing for, and to help us better understand this nitrate transport. So much emphasis has focused on phosphorus and dissolved reactive phosphorus, but nitrate seems to behave differently. And I did see one quote that about 80% of the phosphorus, or some research that showed about 80% of the phosphorus is in about 10% of the storm events. Whereas for nitrate, it was closer to 50%. So while storm event transport is important, there's still a lot going on that's a little bit different with nitrate that we need to understand. And we're going to, again, help promote those non-point source implementation strategies and share the results of those ACPF assessments showing the structural placement of BMPs. Continue on-farm research trials and promotion of BMPs. Amber's going to talk about that next in some of our projects. And overall, utilize the integrated baseline water quality data, the ACPF assessments, and SWOT modeling to inform our outreach, to help target practice implementation, and help measure the overall BMP effectiveness in this watershed. And then continue sharing results on webinars like this with you and local community and our project partners. And with that, I thank you for your attention and time today, and happy to answer any questions that may have come up in the chat. And I haven't been monitoring the chat, so Jocelyn, I don't know if there have been any.
I haven't seen any come in yet, but we'll give it some time, and they might come in. Heather, that was a wonderful presentation. Thank you for that. And Amber, you are up next.
Yeah, let me share my screen real fast. Okay, and let me present. Did it stay on the correct
Yep,
screen?
it looks good.
Awesome. Great. As Jocelyn said, I'm Amber Emmons. I'm one of the water quality associates. She kind of gave you a background of I'm in Wood, Henry, and Ottawa counties. And a lot of what I'm going to talk about is either going to pair about with what Heather talked about or what Vince talked about. We're just going to give a general kind of research update about what the water quality team does, because sometimes, given we have a water title, we get asked, what do we do with water? Do we do water testing? Do we do all kinds of sorts of things? And even though we have water in our name, a lot of our stuff tends to be with on-farm research, row crops, best management practices. So this is a little bit at least what we do that relates to the water and the title of our job. So I'm going to talk about a HABRI project. And we refer to it as the HABRI project, which is the Harmful Algal Blooms Research Initiative, who funded the project. And it was basically, we looked at the impacts of manure on soil health, nitrogen rates, water quality, and farmer profitability. So if I'm referring to the HABRI project, even though they're who funded it, this is the project I'm talking about. I'm going to talk about this in the first half of my talk. So kind of getting into that, we had 2 different experiments funded by HABRI. This was all done in Northwest Ohio. We tended to try and focus somewhat in the Little Auglaize watershed to pair with some of our other Delphis and nitrate and phosphate data, but not all of them were there. We did 20 sites in 2022 and 15 in 2023, but it depended on what experiment we were talking about. Our first experiment, experiment 1 as I'll refer to it as, was manure as a side dress material versus commercial fertilizer. So generally we had the farmers use their manure or use another farmer's manure, which a lot of it tended to be swine or dairy, a liquid manure, and they side dressed with that side dress in corn, generally V3, V4, V5, depending on what kind of implement they used to side dress. And then they left us a couple strips, preferably at least 3 or 4 for our replication, that they used their commercial fertilizer, whatever else they would have used if they didn't use manure as their side dress material. And we just wanted to compare that. Our other experiment 2, was a little bit different. We looked at paired fields. So this was either done with the same grower, 2 fields nearby that he manages the same way, or this was done on research farms across the state, whether it be in Wayne County at Worcester at ATI, Northwest Research Station in Wood County, or down in Western Research Station in Clark County. And they took, again, paired sites, but the difference was maybe one had a history of manure. It means manure had been applied there sometime in the last 5 years, or in my other one, has never had manure. In the last 5 years and beyond, hasn't had manure applied. So that was our comparison of these soils have had or have not had manure applied to them. We did a bunch of different samples when we looked at this study over the 2 years. So in each field, we have a nice little visual to show what we were doing. In experiment 1, we just had the replications going across the field of either manure side dress or commercial fertilizer side dress. And we did several different samplings. We soil sampled prior to the manure side dress. So usually we were out there maybe a week, if not the same day before he was going to apply, trying to get some soil samples in those plots. And then at the end of the year, right, as close to harvest as we could get. Sometimes it was the combine was a couple strips over and we're in the row, or we'd come out after he had been there. Kind of depended on what we were doing and with the farmer. We'd say it soil sample at harvest. We had a few fields actually in this one as well that we had fall applications where we'd look at the farmer applied manure in the fall after his crop was off. And then we looked at the crop the following year to see if we saw any effects because of that. When we would have saw soil sampled before he applied his manure in the fall. Generally October, November, December, depending on environmental conditions. We also did some tissue sampling. So these were all cornfields given they were side dressed. And we took ear leaf samples at R1 or as close to R1 as we could get. And then we also came back at black layer and took some corn stalk nitrate samples. Also, we did water sampling. This is where it comes into, I'm going to specifically talk about the water samples because it's a water update. In all of the fields we were doing, we took water samples from tile outlets. So we were kind of picky in the farmers we worked with. Now, out of all the 15 or 20 some sites we had both years, not everyone had tile in their fields, or maybe it wasn't just that tile drained that field. So we were kind of selective, and out of each one, we probably did somewhere between 5 and 10 fields a year that we actually water sampled. So during the time that they would be sampling, this is usually about May and June, we would do weekly samples, come out there to the tile outlet structure whenever we could in our schedule, grab a grab sample and move on. The rest of the year we come and do bi-weekly sampling. So July through April, we do bi-weekly sampling. These generally we tried to start around April or May prior to the side dress application or any kind of nutrient application. And then we went to the following March. So that way we encompassed that almost an entire growing year for that field to kind of encapsulate what was going on for that year for that field. Then we also, at the end of that, we started the next fields. So 2022, we did water sampling from May of 2022 to March of 2023. And then April 2023, we started our next batch of fields for the 2023 growing season and went with those till March 2024. Now, experiment 2, we just did a little bit differently. Still the same soil sampling schedule and still the same plant sampling schedule, but we did not do any water sampling in those fields when we just used a comparison of nitrogen rates. So these you can see as our little experimental design had a lot more little blocks, I'll call them. These we had paired fields with different nitrogen or with varying nitrogen rates. We tried to look at, does a history of manure, if you've ever applied it, affect your optimum nitrogen rate? So we had used, I believe it was 0, 50, 100, 150, and 200. Generally were our application rates. And we tried to see if we saw the manure field or the non-manure field had a difference of what the optimum manure rate was then, but no water sampling in those fields. So I'm going to focus a lot of my stuff on experiment 1 from now on. So when I say we were water sampling, we were in the ditch, in our waders and our boots, going down to the tile and grabbing a sample. This is what it looks like when it was great. It was nice and easy. You could get down there, whether we used some kind of grabber or we went down there ourselves, kind of depended on the ditch, kind of depended on how easy it was to get up and down that ditch. Was it super muddy that day? Like some of the environmental conditions, but that's generally what it looked like when we were down in the ditch. This is what we were doing. We'd go down there, take some measurements to get the flow of that tile. We'd also collect 2 samples. One would be a 200 milliliter sample of unfiltered. So we just let the towel run into that bottle, move on. The next bottle would be a 100 milliliters filtered. So you can see at the end of that syringe, there's a little disc. That's our filter we'd attach to the end of the syringe there, and we'd have 100 milliliters that we filtered out. And then those would be sent on to Columbus, and they would be analyzed for the nitrate and phosphate in them, and that's what we were specifically interested in. Now, the fun part was always before, and the farmer tells you where your tile is, but sometimes it's not perfect. We had fields where the tile was basically even with the bottom of the ditch. So there's no way for us to even measure anything that's coming out of it because it's basically running straight into the ditch. The ditch water is almost always above the bottom of the tile. Those did not work out. This is why we said we only had maybe like 5 to 10 of the actual fields that we looked at have water data, the rest did not. So then you find ditches that it's okay, it's above the usual water line. I can get down there, I can crawl down there, it's not hard to access. And those are the ones we used. So that was some of the fun parts of trying to go out and find the tiles when the farmer tells you it's somewhere and does it actually work with what we want to do. So going on to some of the data now. I have not done all of these, and some of this is in work with Paige Garabrandt, but she is not here today. She's still on maternity leave, so you're going to get me to explain some of this. So I believe we completed all the 2022 fields. We have all of that data in, and I'll show you 2 examples from that year. When I'm going over these graphs, nitrogen will always be in green, your phosphorus will always be in red. It's in the concentration, so it's milligrams per liter. The blue bars are for that entire year we water sampled, what was the rainfall amounts. Now the x-axis will depending on each graph, depending on where your spike was and how much that field had in its nutrient runoff. It kind of depends on actually your precipitation will also depend. So if you see different numbers, it's just because of how zoomed in or zoomed out that graph is depending on the data and the points. So getting started with this one, this was a field from Wood County. And you're going to notice the phosphorus data does not continue on. We did have issues sometimes with running stuff in Columbus. There was issues with some of our stuff was backlogged and didn't get run for a while just because they didn't have people or the equipment broke down. There was also the fact of it's on-farm research sampling. Sometimes things you couldn't get to it. Maybe there were issues with running the sample. Maybe the ditch was full that day because it had rained a couple inches. So this is all just as it should be with on-farm research. So this one was in Wood County, an example of one of ours. And you can see the red arrow is about when that side dress application happened. It was in late May that year. And you can see any of the taller peaks, there was a couple of days we almost got 2 inches of rain in there. But we're not really sure what to make of some of this yet. We're just finally getting through this because as of a couple months ago, we finally got all of our 2024 data. So it's been slow getting all of this data, and it should have been probably run a lot sooner, but finally getting around to some of it just because of hiccups. But we're not really sure what to make of all this yet, but we're starting to try and look at and see, can we collaborate peak rainfall events with maybe some of those peak nutrient runoff events? Can we also maybe see maybe there's not a reason, maybe there was a reason. Does it collaborate maybe with when their harvest would be? Does it maybe collaborate with when the nutrients were applied? So we're going to start trying to look at it for some of that reasons, but that's what we got for now. Here's an example of one in Henry County, and this is an example of, this is a field we actually went and did all 2 years of the experiment we took water samples from because it was a field right next to the one we used in 2023 then. So in 2022, in late June, it had its manure side dress, which is the first arrow. That second arrow would be approximately when he harvested in November that year. And then the last arrow would be when he planted the next year, which it went to soybeans. So because it was a field we used in 2022, and it was right next to the field we used in 2023 with this grower, we continued on just to have 1 full year of data, or as close as we could with a year of data from one of the fields. And again, the y-axis in this one are different just because we have smaller peaks. We only go up to maybe at the max of 15 milligrams per liter, so it's a little bit different. But do those rainfall events collaborate with some of those high peaks? I don't know. Do we have a reason for that? Again, we were only sampling every week or every 2 weeks, so we were not there all the time, but we're going to start looking at that. This is some of the ones. Now, this one and the next one are from 2023, and I don't have all those samples in yet. We were missing a bunch from about October to March, that last end of that year, and we finally got them, but I have not got them added into our data set to then be run. It's also the fact of, you're going to notice there's periods in those lines where you feel like there should be more points, but this is Northwest Ohio. In the late summer, early fall, our tiles don't run. We get very dry. So there's also going to be the point of some of the data points that are missing aren't necessarily missing. It's just there was no water running. I can't go out and grab a sample if there's no water. So there's also that. And especially in 2023, we saw from about somewhere between August and September, maybe even October, at that point, the tile went dry and we had nothing else to grab until maybe January or February of the next year in 2024. So there are weaknesses of this data to say that there will be large gaps where there's just nothing running, which doesn't mean anything bad. It just represents the truthness of that farmers have tiles out there, but later in the summer and fall, they won't run. So looking at this one, that first area is about when that side dress application would apply. And then the last area was probably about when he was harvesting. And we're going to work on getting weather data. Paige was the one grabbing all the weather data, and I didn't want to make sure I didn't grab it from a different site. So we're going to wait till she gets back, which should be towards the end of the month, and we'll start getting all this together. But you can see nitrogen is the one generally for all of these graphs that we're seeing has the larger spikes. The phosphorus stays pretty low. This is my last one. This one and the one before were both in Van Wert County in 2023. But again, nitrogen is our one that kind of jumps all over the place, and the phosphorus stays pretty low, which at least in some of this area, we're concerned about the phosphorus going to Lake Erie, so that's a good thing. But we're trying to figure out why, looking at this data. And from here, I'm going to shift points a little bit and talk about my side of Delphus, of what I do at Delphus, or the team does at Delphus, because necessarily what Vince looks at for the Delphus site or what Heather's looking at the Delphus site aren't necessarily what us and the team do. So like Heather mentioned, it's the Little Algaze River is there in that red arrow, kind of gives you a point of where it is in Northwest Ohio. You can also see a zoomed in point. It's kind of between Van Wert, Delphus, and Spencerville is what we're looking at. And my side is the daily maintenance. We're the ones grabbing samples. We're the ones making sure these things actually run. So it looks like this. If we're out there grabbing samples at the sites, which Heather mentioned, one or two of us along the road doing the same thing. So we have a one unfiltered and one filtered sample. We're also making note of the height. So we'll drop a tape measure down, get it to the surface of the water and take that measurement. But this is generally what it looks like when we're the ones out there grabbing those samples. Looks like something like this. If you drive by and you see one of us like this is what you'd see probably. Nothing fun, nothing showy, but that's what we're doing. Then we kind of put that all into this data sheet where we put the date, the time, the stream heights. And like I said, those stars are where we're at. We're almost pretty much exclusively in Van Wert County. There's two right on the county line of Van Wert and Mercer County, but just kind of give you a reference if that's where we are when we're doing this, when we talk about this project. So this Delphus nutrient reduction product, what does that mean for us? As Vince said, these are our new labs out in the shed. We have a little shed out there. It's not much. I won't say it's a lot, but it's enough that I could go in there. There's a couple space heaters. If I'm doing this in the winter, it's not too bad. This is what it looks like a lot of times in later summer when it gets pretty low. You can actually see back there. Let me see if I can get a laser pointer to work. Back here, I can see the barrier now. And this is what Heather talked about. When it gets dry, there's no water coming into the reservoir. The river will actually be lower than that barrier. We have nothing coming in. And that's when it gets to be at this point. It's not really flowing. It's pretty stagnant. There's not a lot of water at that point of the year. And that's when we have this nice scummy water look. And it looks pretty disgusting, but it's what it is out there for us. The other fact of it may be sometimes it looks like this, and I have to worry about, is my shed going to flood? Do I need to keep things up? How high is this river going to get? I think in the time since I've been here in the last 3 years, I think I've had it get into the shed once, which was only maybe to the bottom to the floor. But it's the concern of it can be entirely different during different parts of the year. And I'm the one out there making those decisions. Do I move things up? Can things be moved back down? Do the space heaters need turned on? So we're just the ones out there. Does the syringe need cleaned out? Is it skipping when it's trying to move? Is it, what else have we done? Sometimes the tubing after months will get stained with the sediment and everything in there, and I'll change out the tubing lines. We've done about anything and everything to those machines, and usually it's a call to Vince, and he's usually walking me through something. Sometimes it's Max, who's one of his helpers out there, but we're the ones in this little shed kind of just day-to-day maintenance, making these things run, at least for us from the water quality team. So for my impact, I'm looking at this to see, okay, yes, there's data coming in. I'm not necessarily caring about that. I'm looking at right here. This is what I care about. How warm is that shed? I need it to be above 0 degrees Celsius because otherwise our lines will all freeze. And the concern is in the nitrate one, there's a glass tube where the water runs through, and that will shatter if it freezes. It's happened once, but we generally try and keep it above 0. So at the end of the day, also, I'm looking, okay, yeah, I see data, and this is actually the data up until, I think, yesterday morning or yesterday at lunch. But I'm not necessarily concerned day to day what those values are. I'm just concerned the values are what they should be, probably in the range. Because that means I'm not going to get a call or an email from Delphus guys saying, hey, I can't see the data. Hey, I need to see the data to know if I can let the water in. This is just, it means everything's good. It's working as should be for me, and that's what I care about. It's also, like I said, I can see my temperature over time to see. I haven't got below 0. You can tell I was colder beginning here. We've been trying to monitor to hopefully turn our space heaters off pretty soon, but still pretty cold sometimes overnight here. We're hoping for spring soon, but that's at least on my side. It's a lot more maintenance stuff. Yes, we like to present sometimes on the science side of it, where what are the nitrates, what are the phosphates, what do we see in farmers do? Do we see a difference? Do we see a trend? But my side of it and the team side of it tends to be more of the maintenance side of just making these things run. Does everybody work? Is everything working? Can I keep Delphus happy? Can I keep the team happy of just day-to-day running of these things? And that's what I've got. If anybody has any questions, let me know.
Amber, you forgot to mention the leeches that like to get in our tank.
Oh yeah, so in the cone where we bring all of our water in, it's pretty gross sometimes, and there'll be all these little crawly things on it, and you change out that out. Definitely use gloves all the time. And there'll be like little leeches and little fun things. I wouldn't just stick my hand in to grab that filter. It can be pretty disgusting at times.
Well, that was a great presentation. If anyone has any questions, and that goes for any of our panel members, give me just a second here. I will get this pulled up. If anyone has any questions for the panel, please feel free to put them in the chat, put them in the Q&A box. If you go home tonight and you think about something and you want to email us too, that is totally okay. We will gladly respond and get those questions answered. Another item that our team does currently, just as far as kind of outreach for our area, is the cover crop roundtables around the region. We have these roundtable meetings in 3 different locations. We have them in Paulding, Wood, and Auglaize County. Currently, I believe Paulding is the only one starting to run throughout the summer. So Rachel will be hosting that on Tuesdays, and those will be on May 6th, June 10th, and July 8th. Feel free, you can reach out to her or anyone on the team and we can get you that information. I know Amber and my roundtables will start up in the fall. Amber's are on Wednesdays and mine are on Thursdays. So we try to get them within the same week or relatively close. Sometimes we try to make them on the same topics. So if you missed one, you can't make it to Paulding, well, maybe I can make it to Wood, or maybe I can come down to Auglaize as well. So that is just an option available to any of our cover crop people or people who are interested in cover crops or conservation practices in general. That's a way for us to kind of meet face to face, excuse me, and get in touch with those guys. So with that, just a thank you to everyone for joining us. Thank you to our wonderful speakers and presenters. If you guys have questions for the OSU Extension Water Quality Team, please feel free to email us as a group. Our email is waterqualityassociates@osu.edu. You can visit the team as well. It'll have our individual emails on there and all of that stuff there if you're curious about separate projects or anything like that. The webinar recording of this will be posted on the Ag Crops Agronomy YouTube page, probably in a couple weeks to a month. And we will send that out to everyone who registered. That way you can watch it, but that is posted online at the Ag Crops YouTube page. So with that, thank you guys very much and you have a great day.